it was done at night, which reduces the possibility for like refractive fluctuations.
What this
Normalizes the
thing
effect.
is, this observation, the what it is and what it's proposed, should work anywhere, any place, regardless of the temperature, regardless of anything. It just has to be like dawnish, duskish, where you can still see a star, where you can still see a peak in the distance occlude a star. That's the only kind of like time frame of the day requirement because that's part of the observation tool, so to speak. But it should be able to be done anywhere, period. Because all you're doing is 'cause wherever you are on Earth, like Riggs pointed out, you control your angle because you know how far you are from something and you can know the elevation because man has recorded the elevation of everything around him. So
Mhm.
based on those two measurements, you can control the angle, and it just so happens that when you see a star occluded by the peak that you know the elevation of, and you go into stellarium, which is why it should happen anywhere, you go into stellarium, you take off refraction, and you put in you look up what the angle is from the top of that peak to the star at that moment in time. It just so happens when you do that, the angle that's shown matches the angle that you have control over. Because of course, if you change the angle, if you go further from the peak or closer to the peak, it's going to occlude at a different time based on
Mhm.
your observation. That's just a fact. And so if you go into Solarium and you do the same thing, it matches the angle which you set up
Are you
through just.
confident in that?
I'm saying that's what the
I
experiment
am.
is.
Well, that's one observation. Are you confident that would happen every single time? Because my understanding is that Riksky is actually getting ready to do this.
Yeah.
Are we taking bets?
I was just using a celestial refraction calculator and entered some of the values. And the expected celestial refraction would be like 0.5 arc minutes, which would not nearly be enough to get us back to the globe.
And how about terrestrial refraction?
I haven't calculated it, but apparently at those elevations, the globers say terrestrial refraction is negligible.
No, I mean from the observer point to the mountaintop.
No, that's exactly what I'm saying. Because Jesse and other globers do their theodolites on the top of a mountain. They say that at that elevation, it's not really, doesn't really matter.
Well, the thing is also where Mike lives in elevation is so high, it's almost already negligible from his starting position.
Yeah, that's what I found. That's what I found researching it.
So this is what I was trying to figure out is like, okay, does this change when you get closer, like lower in elevation? Or does this even hold true in the south? Because like, dude, it just makes me wonder, like, how does this work when we test it all over the place, like different elevations and in the south?
It should work
If
the
we can
same
actually
anywhere.
triangulate, well, it just makes me wonder if we can actually triangulate the sky, or if it truly is just a projection and we can't necessarily triangulate it.
Well, I don't suspect
How you're
that everything would change north to south. Like it should work in the south.
Well,
I'm just saying.
because I mean, you're not curious about the geometry of things, but we are.
You know, Risky or Riggs, what you just said is exactly what I was hoping they were going to do when they were in Antarctica. If they had recorded, by sort of the same kind of experiment, the angle of the sun to their position throughout the day, being it going in a full circle, they could have triangulated the distance.
Didn't they? I feel like they
No.
did something like that.
No, they didn't. They measured the arc angles to see if it matched something else, but they weren't taking the angle of their position to it throughout the whole day. Which again, that's your a squared, b squared, c squared. You could have gotten the distance. There's a lot of measurements and stuff they could have done. Like they could have taken their angles and had it like Jaren supposedly had it to where everybody else was supposed to take. No, he had it to where solar filter images. But the one I wanted everybody to do was if everybody around recorded their angle to the sun, like in reality, and compared it to theirs, that would give a triangulation of the sun. Completely. It would do so much to mapping out the model.
I'm almost certain. I'm gonna look for it. I feel like they did something with the elevation angle of the sun.
They were measuring the dip. They were trying to see the degrees that it dipped as it went through the day. And they were trying to see if it matched the globe prediction or the flat earth prediction in that sense. But as
Well,
far
that
as
should give you the
taking
same,
a measurement,
yeah, that should give you the same numbers you're looking for, though.
no, like if with the experiment that's being done right now, like if they had gotten close, like you know how they went far enough from the camp so that the mountaintop didn't obstruct the sun? If they had gone close enough to where the sun was just obstructed by it or occluded, then what they could have done is they had their distance, they have the elevation, and they have that. Then again, the same thing, solarium, get the same degree. But then doing that simple calculation, anybody else that did the same calculation around, those calculations together could help triangulate the true distance of the sun.
Yeah, I'm not sure that would work.
Well, it doesn't work on a globe idea. That's the thing. It's how you would get the calculation for the distance of the sun on a flat Earth.
Hmm.
Everybody too busy bickering.